What's up, friends? It's that time again. We're going to do some math. And I want to just tell you, we're going to work on some fundamentals today. We're going to talk about common denominator, okay? And then if we have time, we'll do a long division for fun. Okay, let's hook it on. So let's first talk about, let's find a common denominator. So let's get some strange fractions. I'm in blue right now. And let's make this a minus because we're going to have fun with it. And let's say, fourths, right? What does that equal? Okay. 3/7. This is a 7. I have a slash through my 7s to not be confused with 1s. It's an old math professor, mathematician thing that just kind of happens. 3/7 plus 8/5 minus 1/4. What is that? Now, a lot of teachers have accepted for you to turn these into decimals and give an answer in decimal form, okay? That's not what we're doing, okay? So these cannot be combined as they are. Now let's talk about what each of these numbers are. This is a division. It is 3 divided 7 ways. This is division, okay? So this is actually, when you think of order of operations, do you remember our order of operations? PEMDAS, but of course, Ms. Thompson doesn't like that, so she calls it PEMA, because multiplication, division, addition, subtraction are the same. But so division, right? Division comes before addition. So that's where these fractions have to be dealt with first. Okay, we're going to erase that because I don't want it on here. So the fractions have to be dealt with first, no matter what you do. And yes, you can get an answer in putting this in your calculator, but all you've actually done is converted these into base 10. Because deci means 10, okay? Decade, you know that word? Decade, right? 10, dec, okay? Not like a deck in your house, okay? So all you've done when you convert is, so just go over decimals for a second. Let's say I have 0.27. That is just the same as 27 over 100. 100 being a base 10, right? That's 10 times 10, base 10. So it is a base 10, which is a decimal, right? But that's not what we want. But that's really all you're doing, is you're converting these to decimal form, and then you're adding it in decimal form. So you actually are doing a common denominator when you put it in your calculator. But I want you to understand, it doesn't help you if the calculator knows what's going on, but you don't. Okay? So we are going to look at our denominators. Okay? So remember, numerator, denominator. Okay? Numerator, number, okay, numerator. So this could be said, this is how many, okay? Denominator, nominate, nominal, nom is name, number over name. So name is how many of what? We got a couple of questions in our fractions, okay? When you're doing pure numbers, you say 3 out of 7, right? But when you're doing fractions, when you're in your real world example, you could say 3 kids. I've got 2 books, 7 pencils, right? So numerator over denominator. Numerator, denominator. Okay? How many of what? Okay, we're going to rewrite our fraction. So we'll leave this up here for now because it's nice and purple. It'll be the only thing in purple for a while. Okay? Now, we have to get the of what to be the same. So the how many, the numerator, the numerator will shift when we talk of the of what. Okay? But we first have to find a common of what. All right? It's probably our problem in the country today, right? In our world today, we don't have a common denominator. We don't, it used to be being an American was enough, and now that's not enough for people to say they get along, I don't know. Everything changes. Okay. Hashtag don't be topical, Becca. Okay. So we've got, what are our denominators? We've got 7, 5, and 4. So we need a common multiple. Sorry, I got the cursive in there. Common multiple. So a common denominator or the same denominator is a common multiple. Okay? Now, this might ring a bell in your brain. Do you remember these from literally elementary school? Do you remember those? LCM, GCF? Greatest common factor, least common multiple. These got confused all the time. We are not dealing in this. This is really good for algebra, okay? But we're talking about multiples today. Here's the irony. The G and the L, least, we should probably do a whole video on this. The L of least, right, makes it seem like it's going to be a smaller number, but actually the least common multiple is larger, typically larger, sometimes equal to, all the numbers in the set. So our least common multiple of 7, 5, and 4 is going to be bigger than all of them. Meanwhile, the G of greatest, right, I got to rewrite that. The G of greatest makes it seem like it's big, but this is actually usually less than. If we were to look for the greatest common factor of these, there are none. So that's what we're dealing with, the least common multiple, okay? We don't want this today. So let's go to our numbers if we're going to find multiples. So we have 7, 5, and 4. Now we're going to take this the slow way because this is Miss T, the math geek. This is Miss Thompson, okay? And if you get this, if you already get this really free and clear, you likely won't be on this video. Or if you're on this video, you can skip past this. Or if you actually are like, what's she going to do next? Please watch along because there are 1,000 ways to get this. We're going to do multiples of 7. So we're literally just going to count by 7s. 7, 14, 21. I'm going to tell you right now, this number is actually going to be kind of big. I did that on purpose. 21, 28, right? We know these multiples, right? 35, 42, so on. So we're counting by 7 every time, right? 5, 10, same thing. 15, 20, 25, 30, 35, 40, and so on. Okay? 4, count by 4s. 4, 8, 12. Right? 12, 13, 14, 15, 16. You literally can use your fingers. There's no shame. Just use those fingers. Why do you think God gave them to you? Where do you think these numbers come from? All right? 36, and so on. Now, you might already notice we don't really have a common multiple yet. We didn't find one, but these are multiples. I find a common multiple between 7 and 5. And I can find a common multiple between 5 and 4. But I haven't been able to find a common of all of them. Okay? Now, this is where you have to do it unless you want to exhaust the list. Again, I know this number. It's actually it's actually kind of unfair of me because it's just multiplying them all together. That is a common multiple. And it is actually, I believe this is multiplied by 2. It'll still be the least, but let's check it. So the factor trees of 7 are 7 and 1. The factor tree of 5 is 5 times 1. And 4 is 2 squared. Oops, equals 2 squared. Okay? So to find the LCM, you actually have to do all the bases. And these are 5 and 7 are prime. I should have picked different numbers. But you were there when I watched them. We don't have to do the 1. These are the prime factorizations. So 7 is prime, 5 is prime, 4 is not. So you have to do the base to the higher exponent. And so since they don't share any, it's going to be all of them. So this is actually going to become 20. This is 140. 5 times 4 is 20. 2 times 7 is 14. And then you just add a 0 for the 20 in case you're curious how we did that. So 140, you must be like, oh, why did you do this to us, Becca? 140 is our common denominator. Okay, so we know we're going to have 140 plus 140. And then remember, this one is minus though. Minus 140. What is that equal to? We'll have a question mark for now. So now, do you see our form? These are all blank because we don't know what they're going to become. They scaled up, right? I'm going to show you what we're doing, but on this, so zoom in, zoom out. That's what common denominators are. It's like, what is 3 over 7 when we zoom out? What is 3 over 7 when we zoom in, right? What does it look like numerically? Okay, so let's rewrite this. We'll do purple every time of our original. I hope I gave this a shake. Sorry about that. So we're for our original, we're going to do it in purple. 3/7 plus 5/8 minus 1/4. 3/7 plus 5/8 minus 1/4. Okay. So to get to 140, 140 was all of these multiplied together. So the 7 was multiplied by 5 times 4. That means the 3 needs to be multiplied by 5 times 4. And 5 times 4 we established is 20. So we're going to leave that. Actually, let's do red. What color should we do? I wish I could ask you. When I'm in front of my students at school, they tell me. I'll tell them, should I do green or blue? Okay, are you with me here? Because 7 was already multiplied by 140 to get here. We're going to have 7 was already multiplied by 5 and 4 to get here. So that means we multiply 3 by that. Now, next one. 5 over, it's not 5 over 8. It's 8 over 5. Come on, Becca. Come on now. That's a fun one, though. So because 5 was already multiplied by 4 and 7, that means 8 needs to be. What is 4 times 7? Can we do that in our head? Hopefully. 4 times 7 is, in fact, 28. Oh, yeah, we did have a comment up here with these two. See it? 28. Do you see it? So we had common pairs, but not all 3, okay? And then the last one, if 4 was already multiplied by 5 times 4, so now we need to multiply the 1 times 5 times 7, excuse me. And so that one's actually easy because 1 is 1. So that is, we'll do this in green again, is 35. Okay? Do you see this? Now I could rewrite it. I always tell my students, don't erase. And I really don't want you to, so we'll try to get this where we can see all of it together. What colors can we get? Do like a fuchsia-y thing? 3 times 20 is 60 over 140. Plus 8 times 28. Ooh. Now, you might need a calculator for that, but I want to do a challenge for you in your brain. I'm going to do 8 times 20 is 160, right? Because 8 times 2 is 16 and add zeros. That's 160. 160. 8 times 8, so hold that in your brain, 160. 8 times 8 is 64. So now I've got 160 plus 64, which becomes 224. Check me. Pretty sure that's correct, okay? Minus, and now this one's easy. We already talked about that. The big challenge was the 8. Okay, now that we did that, here's the fun part. The denominator is 140. Here I come to save the day. Okay, since we did this, and since we've come so far, let's do this. It's fun to do in your head. I don't want you to do it in your calculator, okay? We did this one in our heads, but I'll show you the long division, or excuse me, the multiplication. 28 times 8. 8 times 8 is 64. Oops, I wrote the 6 down. 64. 16, right? Remember how your teacher taught you this? And I'm your teacher too. So 16 plus 6, right? And that's 16 plus 6 is 24. Or excuse me, 16 plus 6 is 22. What do you know, right? That's the arithmetic. That's why you learn it how you learn it. There are 1,000 ways to multiply. But let's add these up. And let's do it nice and slow. 60 plus 224, and then we're going to subtract. Okay, I don't want to cross-pollinate with my negative right now. 4, 8, 2, and now we'll subtract. Minus 35. We can do it in the same scale. 4 minus 5 is going to be, well, we can't do that, right? So what do we do? What do we good math students do? We borrow. You borrow. What you're really doing is you're taking the 10, and you're not borrowing, okay? Whatever you've learned, that's just the phrase, but it's incorrect. You're just using one of the 10s, but not all the 10s, okay? It's like changing in a $10 bill, but you only really needed $1 out of it, right? You don't need to take all of it. 14 minus 5 is 9. Oops, I still have red. 7 minus 3 is 4 and 2. So all that said, big applause, 249 over 140. And then you celebrate. But if your teacher was extra frustrating to you and said they wanted this as a mixed number, you'd have to divide it and subtract the 140. So actually this would become 1 and 1. That's a mixed number, but what it implies is 1 total plus this. Mixed numbers just mean it's an implied. So look at this. In the number is an implied addition and a division. And I know that gets confusing sometimes. So we're just going to use it as an improper fraction. And end with a smiley face. Yay! I really love my new tablet. It's super fun. Just say to remind you, thank you for logging in. I hope this was helpful. Finding common multiples and common denominators and knowing what a denominator is super helpful.